Welcome to Module 1, Part 1, Background to Linear Equations, brought to you by Team Glaze. After this lesson, you will be able to recognize terms and coefficients in any equation. You will also be able to recognize the different parts of the standard form of linear equations. And if you don't know some of these things, or even if you do, I would recommend that you get your notebook and paper out and start taking notes. All right, let's start with expressions. Expressions, that's any combination of variables or numbers without an equal sign. So no equal sign. Let's look at some examples. As these come up, notice that with no equal sign, they can be any function. We can have square roots. We can have absolute value. We can have lots of variables. It doesn't matter. So how does that differ from an equation? An equation, think equation equals. Okay, two expressions with an equal sign in between them. There's the equal sign. Here's one expression. Here's another. Here's one expression. Here's another. Always with an equal sign in between. Now, we see that we can take an expression and we can change it into an equation just by adding that equal sign. And also notice that we can have functions. We can have things like this f of x here, or a function of x and y. It doesn't matter as long as there's an equal sign in there. Now, each of these expressions and equations contain what are called terms. A term is any of the pieces, usually separated by a plus or a minus sign. So if we look at this first expression, we have the first term is 4x squared, that whole piece. The second term is 3xy, and the third term is 1. And the sign also comes with each term. So if we look over here, x equals b squared minus 4ac, that last term is minus 4ac, or a negative 4ac. Now, this piece right here, you'd think that maybe it had a term of 5x and a term of negative y squared. Well, since there's that square root taking the whole piece, that term is the entire piece underneath the square root. And then we have a z here. And the last one, of course, is just 3xyz. Now, if I were to ask you, what is the second term in that first expression? You'd go back to this first expression that we've already underlined, and you'd count 1, 2 terms. The second term would be 3xy. Now, let's look at the the expressions and equations. They contain terms, and the terms contain coefficients. See these numbers 4, 3, and 1? Well, let's investigate from our terms. Our term is a 4x squared. The coefficient is simply the number in front. That's where the 4 came from. There's a 3 here and a 1 here. Okay, now what if I just have an x? What is the coefficient in front of that x? It's not 0. 0 times anything is 0. That implied coefficient is the number 1. So that's where this 1 comes from. Same thing with this b squared. There's that implied coefficient of 1. So our second coefficient, and this third coefficient, negative 4. Okay, this one, we have an implied coefficient once again of 1. We'll circle that one. We have some coefficients inside. We have a 5 and a negative 1, and then we also have that implied 1 on the z. And that last term, pretty easy, is just the 3. Now, is this an expression or an equation? It's an equation, right? No, it's an expression. There is no equal sign. Remember, equation has to have an equal sign. All right, what are the coefficients then? If you said 3 and 5, you are absolutely right. Just the numbers in front of those expressions. And now, let's find out what lines in standard form are. We've talked about expressions and equations. We're going to take a very specific equation. This one right here. It's got 3 coefficients, a, b, and c. Now, if you have just a number, that's also considered a coefficient, just for your information. Now let's look at some examples of equations in standard forms. Notice they're equations. They have to have that equal sign in there. This first one, I've grouped all of my x's together, all of my y's together, and all of my numbers together. There's the equal sign. It is definitely an equation in standard form. This one, I've got my x's, but where are my y's? It's okay for any of those to be a 0. That's the same as 0 times y right there. So it is indeed in standard form. I can have irrational coefficients, that's fine, like square roots. I can have decimals, like down here. I can have fractions. It doesn't matter as long as there's an equal sign. And I have all of my x's grouped together, all of my y's grouped together, and everything else on the other side. What about this one right here? 3y equals 6. Remember, there's that implied 0 times x in there. So yes, it is indeed in standard form. I don't have to have that x or the y to be in standard form. Let's look over here though. Y equals 2x plus 1. Do I have all of my x's together plus all of my y's together equals all of my constants? I don't. If I simply subtracted that 2x to both sides, then I would. But the way it's written right now is not standard form. I just want you to keep that in mind. What's that idea of standard form? Okay, we're going to give you lots of forms of equations, and standard form is one of them. How about this one? The second equation down here. I have my y's. I don't have my x's. I have some constant terms here, and then I've got a lot of messy stuff over here that I would need to separate out and fix to turn into standard form. So that is not in standard form. So neither of those are in standard form. Remember, a line has just one x and one y, or if their coefficients are 0, no x squareds, no y squareds, and that equals a constant.